And I think we are live. Hello, Open Tech will save us. Welcome to number 6, not 4, 6. We have a variety of guests for you tonight. We have Ajam from Quadrature du Net. I'm sure I've pronounced that wrong. And they are going to bring to us some thoughts on moderation and censorship in a decentralized world. This is something that we are thinking about very actively. In fact, we have a nascent reputation project, which I'm sure will get interjected by Matthew at some point during this talk. We have Sean Dubois, who has brought a super cool new introduction to WebRTC. And I'm actually fascinated to watch this because WebRTC it's so important, and yet sometimes I wonder if I really understand what's going on. So I'm really excited to find out more about that. We've also got Damir. You may know him as Polya. And if you've been around our Rust or end-to-end encryption work or rooms or repos, then you have absolutely seen his work in the Matrix ecosystem. So we're excited to hear from him, his thoughts on the Rust SDK for Matrix, and also his general thoughts on the world and Matrix and end-to-end encryption. So I'm going to hand over to Ajam. Do you say hello or bonjour?
Bonjour. Hi. So my name is Ajam, and I'm with La Quadrature du Net. And so we wanted to speak a little bit about moderation and censorship. And we started thinking about that by asking ourselves questions that were very exaggerated, such as what is our position on censorship of child pornography, because that's an easy place to start with. And on the opposite, what is our position on moderating French fries pictures when there are people with eating disorders? Is that legitimate or not? And we also asked ourselves what is the difference between censorship and moderation. So we have a lot of examples that I'm going to put in what I'm going to say. We decided to go with a gradation because we see moderation as being done by different actors of different scale. So we see a gradation, and at the top of that scale, there is very large entities such as governments. And we think that some content should not be seen by anyone, such as child pornography, and it is legitimate to censor those through the highest point possible, such as governments. But we also have an issue with trusting governments because they have a lot of power, and they have sometimes a lack of transparency and accountability. And also, at least in France, they have a lot of technical ignorance, and so they're really, really bad at anything that happens on the internet, basically. So there is sometimes not enough censorship when there is a lack of resources for the justice system, and so things take a very long time. And at the same time, there is sometimes too much censorship. Like, for instance, there was some discussion about censoring, I think it was terrorist content in less than an hour. And censoring in less than an hour means having automation and bad robots that are really, really bad at censoring things. And we've seen that in the LGBT community, which has been censored on places like Twitter, for instance, for using LGBT words, and robots thought that it was homophobia when it wasn't. And also that kind of censorship makes it difficult for researchers, journalists, or even police people to access those content when they have a legitimate purpose for it. Then the second step of the scale, I guess, would be big actors. So basically, we're thinking about Facebook or Twitter or things like this. And those have positions on censorship that are sometimes supported by the community, but often they're not. And we have seen, for instance, the censorship of nudity on Apple or Instagram. And again, they have too much power and not enough accountability. And there are some very bad examples. And for instance, the Amazon deleted the 1984 books on Kindles, which is kind of a totalitarian move. So we don't want that. And so those examples are places where the moderation is done upstream, so from very big entities. And we believe that they take away the possibility for individuals to interact with those contents. It can be to mark their disapproval. It can be to reclaim problematic terms, such as what the LGBT community does. And it can also be to inform on the existence of things like, for instance, in France, we have had a lot of homophobia going on when we were debating the gay marriage. And people were very surprised about that because they didn't know it existed at this scale in France. And so sometimes censoring things means masking them. Yeah, I didn't say that, but I identify as LGBT, and so a lot of my examples come from that background, but of course they are applicable to other examples. And so we wanted to focus on how do we moderate at a smaller scale. And so the next step on our gradation is the small communities. So for instance, one instance or one discussion space that can have rules that they define together. So for instance, a kid-friendly only content place. But the issue with that we have seen is that some community push towards a lot of radicality because they, for some people, it can be hard to belong, and so they put up rules where they think that it will be easier to include people if those rules are very strictly abided by, and sometimes it gets too radical, and we had an example of that on Mastodon. So there was an instance that was called Witch Town. It's a French instance. And it got so radical that the person who administrated the instance got banned. And so the instance had to close because no one was taking care of it anymore. So that's a case where it can go bad. And the last step, which we thought was very interesting, is the moderation that happens on an individual scale. So for instance, Twitter does that. Like on Twitter, you can hide some keywords. So that's very helpful when you personally don't want to see some content. But it can also be very heavy for individuals to have to do all the moderations by themselves. So we also believe that it's not enough, but we definitely believe that it's a nice possibility. And another issue with this is that it relies on the community to use the exact right words that you've put in your filter. So it can be like trigger warning quotes, or it can be like any words, but sometimes people talk about things without using the same word as you, and that makes things very difficult. And so those rules are really applied on standardized content, like it applies on words that are very specific or on images that are very specific as well. But then sometimes it happens that people insult each other with polite words. Like if someone say, I don't know, gay people are bad people, there is no any bad word in that sentence, but yet it shouldn't be out there. And also we can be unsure if an image fits a criteria. So we had this example of a child pornography image that was created only with a computer, and where no one had actually been harmed. So should that be censored or not? How should that be considered? And then we thought a little bit about what is wrong with those things and why are they still wrong even though they're not very exaggerated. So it's Judith Butler who says that the efficiency of a discursive action relies on its repetition. So the idea is that if someone calls you by a name in the street, you can just say, oh, that's not me. But if people in the street keep calling you by that name again and again, then you start identifying with it. One very good example of that is gender. So you encounter gender everywhere in your life. It can be how people talk to you. It can be that you have forms that you need to fill. It can be the clothes that are available to you in the shops. And so this repetition creates misogyny or racism or homophobia or ableism or everything else. And the very discrete or acceptable forms of those are usually not moderated, but that's what they're the basis of those discrimination. And it can be verbal insults, it can be bias, it can be lack of representation. But really, how do you moderate lack of representation, for instance? And so to a little bit go further than just moderation, what we thought is that what we need to do is to collectively decide what kind of community we want to build together. And instead of only moderating content that is problematic, we can show great content. We can put in the world content that we actually want to see. And we can create and visualize our vision and our values and define a culture, because that's really by defining a culture that you can have an impact on what's being said and done in your community. And most importantly, you have to act and make repeated actions that lead toward that world that we want, and not just empty list of values or anything. Yeah, I was a little bit afraid that I would be too long, so I think I spoke too fast. I'm sorry about that.
That's okay. Thank you for sharing your thoughts. Some people have sent in some thoughts of their own and some questions for you. Actually, there's a really simple one that I had at the beginning. You said, I mean, your context is on France, and in particular LGBT context within France.
Yes.
Do you think that that's any worse than other places? You were quite critical of France itself and their response to digital matters. But are they any worse, or is that just your situation?
No, I'm sure there is a lot of things going bad in a lot of different countries. I don't think France is the worst. It's just the one I have the most knowledge of. But I can see also what's happening, I don't know, in the US, for instance. And I don't think they have a much better understanding of internet or anything.
No, yeah. Can see that too. Specifically on Witches.town, Prescas says that they remember Witches.town and he didn't know what happened. Is there a post-mortem anywhere about that, or somewhere people can find more information about that? Because I hadn't heard about this news.
I'm not sure. I think some people wrote some blog posts, especially the one who created the instance. I'm sure she's got a blog where she posted her thinking about this. But I don't have the link right now.
No problem. So I guess there's one more thought coming out here, which is the concept of indirect censorship. So the example being, I won't federate with you if you don't have a code of conduct, or if you federate with Gab, I won't federate with you, is a common policy on Mastodon.
Yes.
Do you have comments on that? Is there thinking in that space?
I think it depends on what an instance is, and more specifically on what the scale of this instance is. But I believe that that's actually a question we had at La Quadrature, because we have an instance on Mastodon, and we actually discussed whether we were to link with, to connect with Gab or not. And my position, at least, is that the community I want to be a part of doesn't have anything to do with fascist communities or anything, so I don't want to connect with them. Now, I also think that some people connect to Gab and I still want to be connected with them. For instance, I don't know, like journalists or people like this.
Right. Yeah. Sorry. Yeah, I'm reading two screens.
I had a question, Ben.
Yeah, go ahead.
Or actually a comment. I mean, in terms of the idea of actually making a change here and doing something concrete, it's something that we're obviously very, very aware of and thinking about on Matrix as a whole, and trying to design this reputation system that can both be used for managing abuse from a server perspective, but also empowering users to make their own decisions on what content they want to see. And I think it has some solutions to some of the problems that you posed there. For instance, having a taxonomy for tags for things like trigger warnings one way to solve the whole thing that there are many different ways of identifying a particular trigger could be to publish a kind of grey list of reputation of stuff which people have identified as being triggering based on whatever that particular tag might happen to be. So it doesn't matter if people are describing it in English or French or whatever language with different descriptions, if it has been separately curated into this list. A bit like on Twitter, you've got the concept of lists, which are very, very basic building blocks. We're basically trying to build this idea of rooms which can be used to gather grey scale reputation data, and it could be how abusive or how triggering or how positive, heaven forbid, any given particular thing would be. And this is actually getting less sci-fi in the, well, first of all, we're using it already with Mozilla and Matrix's instances for simple block list sharing, and there are like 3 or 4 rooms now which are tracking that. But we also are in the process of hiring a first and safety engineer via Element to go and work on this full time, and hopefully we've got somebody in the pipeline who will be really, really interesting for getting involved in this. And the first step is going to be solving it for basically our legal compliance, to make sure that the servers which we run as Element on behalf of the Matrix.org Foundation aren't like breaking the law. But then the idea is to try to democratize that and build it into the core of the protocol. And one of the fun things there, in terms of your child abuse example, is that I think that the building blocks have to be completely neutral, as depressing as that is, that it needs to be basically building blocks with which you can create a taxonomy. And whilst people, one of the first things I'm hoping that people would do would be to start publishing a block list, or at least a grey list of hashes of content which is illegal because it's child sexual abuse imagery or whatever. It wouldn't be intrinsic to the protocol. So it's basically a morally relative system that would allow people to go and make their own decisions about what they have on their servers, as well as higher order things like, I don't want to federate with this server because it federates with the other server. So sorry, it's one of those terrible things which wasn't a question. It was just an update of what's going on this side on Matrix. But I was at least super happy that we finally got enough cash to be able to hire people to actually work on this properly. And if anybody is interested in this and is listening, there may be scope to expand that team in future, depending on how well Matrix is taking off, because it is something we want to get right.
One of the questions that came up in the chat, where I think the answer is yes, I think Amandine already answered actually, is will these grey list block lists be available to other services or to the other parts of the Fediverse, for example?
Yep. Absolutely. So as it happens, we're expressing them as matrix rooms, but in the end, it's just data, and you can bridge that into any other place you might want to access it. And we can also, we're already looking at actually bridging data in from other systems. So for instance, outfits like the Internet Watch Foundation or in the UK is one of the main bodies who maintains hash lists of child abuse content. And if there was a way to make that available using the Matrix decentralized reputation system, then hey, it's Matrix. We're just bridging into other data sets. And it would be really nice almost to have not an economy, but at least a marketplace of reputation data that people can hook into if they want to block stuff using whatever rule set. And it might be from any faction. I mean, we've spoken about this before when Eugene from Mastodon was on, and then it was a bit more sci-fi, but as the months roll on and as we hopefully hire people to actually work on it, I think it's going to get a lot more concrete. And it's not a problem for Matrix. I mean, it's a problem for everything on the internet, even a problem outside of the internet. I hear that reputation in real life, people can also sometimes be like one up.
So it's funny actually, that topic came up in the chat. That one of the themes here is that we would be going back to centralized digital concepts where you choose your environment, you choose your locality, and your block list or your reputation is tied to that.
Well, the Matrix stuff is just shamelessly trying to rip off human society. I mean, we've got this stuff figured out offline for millennia have transitive trust from other people that you know, and you know, people sometimes pump and dump their reputation. Sometimes people lie about it. Strangers start off with slightly negative reputation, but then it kind of gradually increases over time. You get little pockets of cliques who trust each other, and it's just trying to provide the same modeling. And it's shocking that the centralized guys haven't solved this already, because they've had the data for ages, and there is nothing decentralized about this. And there's no reason why Twitter and Facebook can just use the same technology to solve their problems, but they've been too busy saying adverts and rather than actually making life better for their users.
So the smartest people in the world are figuring out how to sell more ads.
Yep.
So while we're here, though, could we have an introduction to La Quadrature du Net? What is their work exactly?
So La Quadrature is a French organization. We're a nonprofit, and we work to defend the civil liberties in an era that is very digital. I'm sorry, I'm trying to translate that. It's not very good. The website says it much better than me. But yes, the idea is that we defend every civil rights that we already have in the physical world, but those rights get threatened by how we use technology, and technology has new issues, and so we're trying to defend those rights, even though the technology is disrupting it more and more.
Yeah. So once again, we come back to this theme of how real life can be adequately modeled using digital tech, and how that hasn't been adequately done until recently. So yeah, this theme keeps coming up. All right, do we have questions coming in? I'm just going to see if there's anything interesting. Couchsurfing. Yeah, it's true. Couchsurfing was working on similar things. This was years ago. I remember this being 10 years ago that they had a reputation concept that was ever so slightly more sophisticated than just voting. So here's one on radicalization. Do you feel like finding a group of peers has a danger of pushing people towards more radicalization? So, I mean, this is back to filter bubbles, I suppose.
Yeah, definitely. Definitely. Also, I think it can be difficult in different ways. Being with a radical group makes you more radical. I'm sure a lot of studies show that. But also, I think that protecting yourself too much can sometimes be harmful, either to you as an individual, but also as the society as a whole. I know there's been an issue on Mastodon where people used to put those disclaimers on topics about police violence. And we've had some, quite a few riots in France in the past years, and a lot of people have a lot of difficulty seeing police violence because they have been involved in it, and it's very hard to see it again. And that poses the question, how do you inform on police violence if you can't talk about it because some people feel uneasy with it?
Yep.
And so sometimes protecting people can harm the community as a whole when you can't talk about the problems.
Right, absolutely. And in fact, I don't know if this was broadcast in France, but there's an episode of Black Mirror, a quite famous episode, quite famous television show here, that features a sci-fi component which does exactly that. It filters content from people, but the knock-on effects of that are far worse than the original designers had in mind.
Yeah, I mean, this is the thing that we'd be most worried about, frankly, with the Matrix implementation, that it is, by definition, letting people create and curate their filter bubbles. And the flip side is that, yeah, it could create more radicalization, it could create more cliques, more polarization, more factionalism, more strife and antagonism and unpleasantness. And so I think there's a huge, interesting UX problem, at the risk of being a geek and saying, oh, we just need to solve this with some software. But I think there is a legitimate UX problem here to solve, where you can basically visualize the bubbles to the user. And it could be as simple as saying, hey, by the way, 98% of the world have filtered this thing out. Or it could be, hey, why don't you just broaden your bubble slightly? And I think there could be ways to gamify it almost, where the user is almost rewarded in exchange for looking around at things from slightly different viewpoints, even though it's a little bit uncomfortable. And you can almost physically visualize that in interesting gamey ways. We've been playing with mapping algorithms, literally going and doing a force directed graph of the various communities, rendering it to look like a map, like physically like a kind of XKCD map of the world. And you can imagine that it's suddenly getting a little bit more interesting to explore around different viewpoints. How about we go to this big blue bit or this big red bit and see what the other guys think? And again, it's sci-fi, but I reckon that if somebody gets that right, and hopefully we'll have a good stab at it, that could mitigate this problem of people just creating ever more strange and nightmarish dystopias of reinforcing their own prejudices. Otherwise, we're straight back in Facebook filter bubbles, except this time it's the users creating their own ones rather than Zuck creating them to sell more ads.
All right, the chat is going on, but I think that we've said most of what we're going to say here. Ajim, thank you very much. Thank you for the introduction to Quadrature du Net. Thank you for sharing your latest thinking on centralization in a decentralized world, because obviously it's something that a lot of people are thinking about, and it hasn't received enough attention because the tech giants haven't done the work. So, on the
Thank
subject,
you for inviting us.
Brilliant, thank you. We have a fellow named Sean Dubois. I think I've got the pronunciation right.
No, perfect.
Close enough. So you're going to talk. You are highly knowledgeable about WebRTC. I wonder, is that what you do during the day?
Yes. So before this, I had written a Go implementation of WebRTC, and so that's how I came out into all this knowledge. And then really the issue was everyone. I thought like the problem I wanted to solve is I wanted to make this stuff easier to use, and so everyone came and used the library, and I realized I didn't solve the problem that I had hoped to solve. People like had the same questions that they had for other implementations, and so yeah, this is another stab at solving the same problem, and we'll see where it fails, and we'll figure out what round 3 of making this easier looks like.
Fab. All right, so we're going to get an introduction to WebRTC right now, so I'll let you take it away.
Yeah. Cool. So I'm Sean, and this is, I guess the topic here is WebRTC and as a tool to enable everyone to communicate and in a way that you control it. So these are like my 2 perspectives on WebRTC. The first is working on Pion, which is just a Go implementation. If you're familiar with using it in the browser, it feels the same exact way. And I came at this from a very different world. Before this, I had worked on media servers, and I had just been building things, and I was not familiar with all of this big decentralization world. And my first foray into this was working with Tor's Snowflake, which is you run Tor over the WebRTC data channel. And I realized how impactful and how important this technology was, and it kind of gave me a calling to work on this. I felt that I had stumbled into something that was worth doing. Before it was kind of just this fun little hobby. And then after that, like the more people I worked with, they said, WebRTC is difficult, I don't understand it. And I thought I just made WebRTC for the curious. It's a Creative Commons 0 book. You can go read it right now, it's on the internet, it's a work in progress. And then feel free as well to copy the text out and put it on your own blogs and do whatever you want with it. Like I'm not looking to make money or anything else. Like I just want the right information to be pervasive. And of course, send us pull requests and make it better. So if you aren't familiar with WebRTC, these are kind of like the 4 high points or what's exciting about it. The first is you can send like unlimited media streams. So if you're familiar with like a video file, you probably think, oh, you have an audio and a video track and maybe subtitles and stuff like that. What WebRTC allows you to do is you can send as many streams as you want. And on top of sending those media streams, you can also send binary and text communication. So I can send, this data channel allows you to send binary data. You could send, a lot of people who are doing embedded devices will send like the temperature readings, and then you'll see a lot of chat apps will send stuff like that. And then the next big one is the fact that it's peer-to-peer. So WebRTC, even if you're like most of the time that you'll use it, you'll actually just be connected directly to the other person. And if you aren't familiar with NAT traversal and all this networking stuff, this is going to sound pretty crazy, but if me and you are in completely different networks, you have, think your home network, you have a public IP and you have a bunch of computers behind it. I'm in my network and I have a public IP and a bunch of computers behind it. We can have our two computers talk to each other, and that's super powerful. There requires some bootstrapping that we'll talk about, but that's kind of the exciting power behind it. And then mandatory security. So WebRTC, you have to run over DTLS. It uses these modern ciphers, and it's just secure by default. There's no optional. You don't have to worry that the person you're talking about has weak security, they've turned it off or anything like that. And then the other story that I've really come to appreciate is that standards like even the playing field. So with WebRTC, I can quickly switch between CDNs. If X provider all of a sudden does something I don't agree with, I can just point my WebRTC client at another provider. I can also bring my own client. So WebRTC, there is a C, there's a C++ implementation, there's a Python implementation, there's a Go implementation, and there's a GStreamer one. There's probably a lot more that I'm unaware of, and that's exciting. A lot of programs you use, they have one underlying C implementation, and that's it. But WebRTC, they have a bunch of these separate ones, and there's a real healthiness to the protocol, and that makes it easy to bring in and use. But then there are the downsides. If you're trying to build something quickly, you probably think, oh, I just want this little piece and I want to build my thing. So WebRTC isn't the right choice. I would push for standardization, and this stuff is slow, but it's important to use it because that makes it available for other people. And it puts the onus on, bigger tech companies to use WebRTC. By them investing in WebRTC and sometimes paying this tax, you're making it better for, small companies and individuals to build these things that are super powerful. And before we get into the deep details, when you say WebRTC, it's kind of ambiguous, but there's two WebRTC parts. First, there's the API, which you use in the browser. Let's say you want to build a video call. You start a WebRTC instance in your browser. I start a WebRTC instance in my browser, and we connect. And that's known as the API, and that's standardized in the W3C. On the other side, you have the actual protocol. And that protocol, there's multiple implementations. So there's the JavaScript one in the browser, but there's also the other ones we talked about. And that's standardized in the IETF. And interestingly enough, WebRTC is made up of a bunch of protocols that actually come from the 90s. So you've got RTP, you've got TLS, you've got SCTP. These are all things that existed way before WebRTC was even a conversation in 2010. And that's really powerful as well. You know that this stuff is secure, this stuff has been tested. A lot of these networks in the middle, they know they work. But using those pre-existing protocols does kind of create this soup. So if you look at all these acronyms, these are if you've ever wanted to learn WebRTC, you get hit with this graph and you think I have no idea what's going on. And that's what I want to try to do, is demystify that. So let's just break down. What we're going to talk about today is WebRTC, the protocol. We're not going to worry about the API in the browser. There's a lot of tutorials out there that do a much better job than I will. So you can go look at those and learn them. What you want to think about is WebRTC is really just a 4-step process. First, you're signaling, which is bootstrapping the call. So if me and you want to talk to each other peer-to-peer, I can't. It's like picking up the phone and I don't know your number. We have to bootstrap the call and give each other the minimum amount of information. The next is the connectivity step. So in a network, there's multiple paths to each other. Imagine if you have two computers connected to each other and they can talk to each other over Wi-Fi. They can also talk to each other over Ethernet. Which one would you choose? Ethernet is probably better because there's going to be less latency. There's going to be less packet loss. But then how do you pick that one? And then it gets even more complicated than that when you talk about, there's multiple routes and all this stuff. So then after you establish that connectivity, then you have the encryption. Encryption does the DTLS handshake. And then last is the part that most people care about, which is all the media and data flowing. So first is the signaling. So signaling is all sharing the minimum amount of details needed for a peer-to-peer connection. And we'll talk about these protocols later, but it's really all about sharing the auth details. It's sharing the username and the user fragment, the user password and the user fragment that are needed for ICE. It's about sharing like the DTLS fingerprint and what you want to send to each other. So and if you've ever done WebRTC, you've probably done the create offer and create answer, and it spits out this giant blob known as the session description. And this is that bootstrap. So what we have here in red, if you want to read what this session description is it's these key value pairs, and it's split up into two parts. What I have in red is the global part of the session description. So right above the M equals audio line, that's like the global state. And then inside that, we have two media tracks. So this green is an audio track. And what this call is saying is, okay, I want to talk to someone, and I want to send them one audio track and one video track. And inside that create offer, create answer blob, you could have way more than that. So after that, you roll over into the ICE. And ICE is this interactive connectivity of establishment. And it's all about connecting and talking to each other. So let's say that there's multiple ways to talk to each other. So we have what we call these host candidates, where if me and you are in the same network, we can just talk directly to each other, and that's perfect. But what if you're in a different network? How do you talk to each other? What you do is a server reflexive, which is a stun candidate, and we'll talk about that when we get down to like how the networking side actually works. And then the last is that relay, which is these turn servers. And don't worry about the details here, but just try to visualize, and that's like what the power of peer-to-peer, or what the hard problem with peer-to-peer is I have multiple ways you can contact me. Like you can contact me via the IP address of my local computer, or you can contact me via the IP address of the public IP that I'm routable through. You have all these gateways that you're moving through, and that's what makes peer-to-peer complicated. Is you have no idea where the other person is actually going to be located. For some WebRTC calls, you might be sitting right next to your friend in the same room. For some WebRTC calls, they might be on the other side of the world. So it's all about finding that best way to talk to each other. And like, what makes the best pair? So if, let's say that for some reason, me and you are sitting next to each other in the same room, but talking to each other via our public IP was the first to connect, that's probably not the best pair that we want. We probably want to talk to each other over the LAN. And the second part of WebRTC, the connectivity part, is all about finding like the best way to talk to each other. It's not as simple as enough as just saying, okay, let's connect and let's go. Like, you want to be able to evaluate like the round trip time, the packet loss, the bandwidth cost. Like, it gets complicated. And the next part is with a peer-to-peer call, you might even want to stay connected on the move. So if you're on a phone call, you might want to walk outside and do LTE, and then you might want to walk back inside and be on Wi-Fi. If you lose that connections, like, you should be able to switch on the fly, and the ICE allows you to do that. So after you're connected, the next part is the encryption. The encryption is actually pretty simple in terms of how WebRTC sees it. So ICE was all about establishing network paths, and now we're able to talk to each other. And what we do is now just a DTLS handshake. So DTLS is just the UDP version of TLS. If you've ever gone to a secure website, you'll see the green lock in the URL bar, and that's HTTPS. DTLS is the same technology. There's a little more extra, but nothing that you'll have to actually worry about. And the one dangerous thing about WebRTC is the fact that you have to trust your bootstrap messages. So if me and you exchange bootstrap messages, what's stopping someone in the middle from modifying those bootstrap messages? In a perfect world, I would hand you my bootstrap message on a piece of paper, and you would put it in your computer, and we would connect it. We wouldn't have to worry about someone modifying it. But if I sent you that bootstrap message via email, what's stopping someone from modifying it? And that's where the danger comes in. And then the last part is the media. And the media stuff is where it gets really complicated. And this is where the power of WebRTC really comes in, the fact that it solves this for you. And what video is that you have these constraints of the physical world, and how do you solve them? So between me and you, we have a certain amount of bandwidth, we have certain hardware, we have certain network capabilities. And like, how do you deal with all those? And we can break it down a little and say like, okay, I know what I want to do. I'm going to send you this video and it'll be good. But that's not how the real world works. It's not that basic. Like, as you can look at these graphs, even on a local network, or just for fun, I generated this, we saw some spikes in different places. And that's what makes it difficult. And underlying that, we have this protocol called RTP. And what RTP does is it chops up these video frames into these little packets so we can send them back and forth. And that's how we deal with the packet loss and the jitter. And what it does is this gives you that visualization. So imagine if I'm sending you a picture that's made up of 6 packets. What happens if I lose packet number 4? What we'll have to do is we'll have to re-request packet number 4 and say, okay, like, please fill in that gap. Or what if our packets are delivered out of order? We get 1, 2, 3, then 5, 4, and 6. What do you do there? Like, do you re-request packet number 4 because you assume it's lost? Or do you wait a little bit? These are like this brings a lot of subjectivity to streaming video, because you don't know exactly what the right thing to do is. It really depends on the WebRTC agent and what they want to do. And to give you an idea, here's GStreamer's RTP jitter buffer, which is an amazing implementation, but it's a complicated problem. And there's a lot of things that you want to decide. Like, if I'm dealing a live video, a live video, and my neighbor is watching the same soccer game, I don't want to be 3 seconds behind, because if I hear them yell, it kind of ruins the enjoyment for me. But if I'm too quick and I'm seeing packet loss and I'm seeing little blips on the screen, like, that's not a pleasant experience either. And that comes to the whole talk about the RTP trade-offs of latency versus quality. Do I want video that's faster, or do I want video that's more quality? Does my screen share matter more than my webcam? There's a lot of stuff in there that is important. And it's all about like making those trade-offs. And to give you more ideas, like, this is an active conversation. I mentioned before that these protocols have existed since the 90s, and like, there is still an active working group in the IETF that's discussing these different congestion control implementations. And there's still papers being written on what's the best for dealing with, a sudden drop in bandwidth or a sudden, spike in packet loss. So those are the technical details, but from what does it actually solve for you? Like, these are the things that excite me to tell other people. Here's the first one I alluded to, which is we have 2 people that are in different networks, and you have one public IP representing multiple computers. How does a computer in network A talk to a computer in network B? The magic here is what's known as NAT traversal. So what will happen is, let's say that when you contact a website, you send a packet up to them and they send a packet back to you. What's happening is that your router is establishing a temporary hole in your network that says, okay, if you contact foo on port 5, foo on port 5 is allowed to send back to you. And there's a temporary hole that's established in your network known as and you can see right there, like, so now, even though my private IP is 10.5.0.6, my router has allocated a temporary port 50345 that people can send back into me. Think about it almost like automated NAT traversal, automated port forwarding. If you remember back in the day that you wanted to play a multiplayer game with a friend, you would go into your router and you'd say, okay, port 5000, if someone sends a packet to that'll go to my desktop. This is automated port forwarding. And that's how that automated port forwarding gives us the ability to then do a conference call with other people. So now that you've created that NAT hole, you can give it out to other people and they can send packets back into you. So the NAT hole is great, but like, what do we do now if we want to talk different protocols? You know, one is IPv4, one is IPv6. WebRTC also gives us this thing known as turn. And what turn is there's actually a server that sits up in another place, and it acts as a proxy between us. So the computer on the right can send to the computer on the left by going through that. And that's also important for privacy purposes. Let's say that you jump into a network and you don't know anyone, you're not confident that you want them to know the IP that's been allocated to you by your ISP. You can use turn. There's been a lot of fear around about WebRTC IP leakage and stuff like that. Like, this is the solution to that. And this is the fun one that I'm always excited to talk about, is the problem of like moving between networks. You know, these days, like if I'm on my phone, I want to continue watching a video, even if I'm walking out the door. With ICE, you can do that. So I'm on a call between these two peers and it's flowing through my router. And then I walk outside and boom, like I can switch to cellular on the fly. And that's really powerful because you can switch on the fly depending on how much bandwidth you have. Let's say like your Wi-Fi gets overloaded with other devices, like a network path becoming unreliable is much more common than we expect. And the next is that congestion control. So when you upload a video, you like to think that, oh, like there's a consistent bandwidth. You know, these two people are talking to each other, and the fastest network between us is 50 megabits per second. So let's set our bit rate to 50 megabits per second, and that's great. Well, what happens when more people come on the call? All of a sudden, the amount of bandwidth drops from one of that hops. And so what WebRTC has is this thing known as receiver feedback. So the person that's receiving your video will actually send back statistics and say, I got these many packets, I lost these many packets, I have this much delay. And that allows the sender to, on the fly, adjust the quality of the video. You'll probably see this when you're in a conference call and someone's face will go blocky all of a sudden. Like WebRTC on the fly is adjusting the quality of your video so that you can still have a usable experience. And that gives you the ability to keep talking, because like if you didn't do that, the call would just go out. Like or you just accumulate a bunch of latency, which doesn't work for live video. You can't talk to someone with more than 400 milliseconds of latency. All of a sudden you start talking over each other and you build up a lot of just like frustration. And then the next one is the head-align blocking. So imagine if I'm sending if we're playing a multiplayer game, you don't want to know where I was 3 seconds ago. You want to know where I was right now. And so what this protocol, SCTP, does is that new data flows unblocked. So I send a packet once, and if you're not available, it'll just drop that packet. So for like HTTP, like that's you need the delivery to be reliable. You need the packets to always arrive, because if you're missing a DOM element somewhere up the page, everything is garbled. But for live video, you don't care about that. Like, why would I care what you said 3 seconds ago? I want what happened right now. And then the next is the MDNS. And this is one of the newer things. But when we talked about those bootstrap messages, that's kind of like, it's a limiting factor to WebRTC. Like, I want to sit down in the same network as you and talk without even doing the bootstrapping. So one of the things I've been playing with is this multicast DNS, where you actually send a message and it's multicasted out, and it says, and you announce who you are. If you've ever looked on your laptop and done the network places or something like that, and you'll notice there's other computers in your network that can find each other. That's what they're doing. And WebRTC is starting to take more advantage of this, which will bring a lot of cool things where people could just find each other and don't have to worry about doing that bootstrap. So next, these are like cool open source projects that I've seen using WebRTC lately. It's a very like decentralized world, so I'm sure I'm missing a lot of interesting things. And if there's something that you want to share, like please drop me a message on the Matrix channel. I'd love to retweet your project or do whatever, like promote it. Like, I think for me, what really motivates me is seeing that joy of other people build their projects. So these are ones that I've really enjoyed lately. So a developer built something called Nintendo Switch Remote, where actually what it's doing is it's bringing in the feed from their Nintendo Switch into their VR device. So they're sitting with a Nintendo Switch in their hands and playing it, but they're actually feel like immersed in the game. So they've captured the video output via HDMI and they're sending it over their network. And now they're playing video games like they're actually in there. And it'll bring like this more immersive experience. You can get more of these devices into your Nintendo Switch and play them. I think there's a lot of promise in like streaming content in the same network into these devices, and just like the IPC. This one is using SSH via peer-to-peer. So if you've ever spun up like a little network and a hosting provider, you probably have a Bastion host where you have all of your servers. You don't want them to be publicly accessible, but you have a server that's on the edge that you SSH into, and then you SSH into inside the network. This drops that requirement. So instead of having to route yourself through, you then can SSH directly into any of those servers. And that uses that NAT hole traversal we've been talking about. So your servers don't have to be accessible to the internet at all times. You establish a temporary hole, you talk to each other, and then you hang up. This is Cloud Retro. And what Cloud Retro allows you to do is play these NES games and way more. The developer is actually working on something where you can spin up Win32 applications on the fly, so you can play, Diablo or start up Photoshop on the fly. And this is all accessible in your browser. And what's happening is you're running this expensive program on a remote server, and then it's sending you the video frames back, and you're sending your key presses and your mouse movement back to it. So it allows you to keep all that state on that remote server without having to worry about it. And it allows you to play with other people and keep your save games otherwhere. I've always been really excited by the promise of thin clients and the ability to move all that stuff elsewhere. Nico's another one. So Nico is the idea that you run a Chromium or Firefox instance in a VM remotely. So I go to this localhost 80, and what's actually happening is inside a Docker container, there is a browser instance running that multiple people can access and play with. And so what I do is I have multiple computers that I use, but I leave one browser running remotely on a Nico instance, and I will access that, and I'll have a bunch of tabs open, and I'll have my chat apps open and stuff like that. And so I keep all that heavy stuff there. I can, shut down my computer whenever I want and not worry about it. And that's also great for like watching videos together and collaborating and doing whatever you want to do. And this is a great one, is the web torrent. So if you're familiar with torrents, one of the big issues with torrents is A, you have to download a client, and B, the protocol is easily blocked. So some ISPs are able to figure out that it's torrents via the packet inspection. So WebTorrent, since it's running torrents over this established protocol that's used for conferencing, they can't easily block it, because all of a sudden they're going to take people down from their conference calls, and you can't have that happen. So WebTorrent is this great project where now we have torrents that are in the browser, so I can go and do peer-to-peer file sharing in my browser tab, or I can go use the WebTorrent on a server. And there's this was the first WebTorrent, the first like command line WebTorrent client that was written, and then there's other ones that have come up since. RTC Tunnel is a project that allows you to access UDP and TCP services from your browser. What it does is, let's say you have like a Redis instance, is you can run RTC Tunnel on your Redis instance, you connect to that, and then you connect to that other service. So that opens up a bunch of possibilities. Like you can do like, you can open Vim, you can do other stuff like that, all via this, which I think is super interesting. It's better, like if you prefer to access stuff and have rich text in the browser compared to just doing like a screen share, or it's basically like an SSH client in the browser. And then you have Snowflake, which got me into the whole decentralization world, and it has sort of the same promises as WebTorrent. So you want people to be able to use Tor, but you don't want them to. You can't download a client because they're in a hostile network that doesn't allow them. and you want it to not be blockable. Since everyone's using WebRTC now, like there's this promise that the more people we get on WebRTC, the less likely things are to get blocked because you can't take down all these existing things. And then the teleoperation one is super exciting with WebRTC, that more and more, especially with all the pandemic going on, is you want to be able to control these devices remotely. To be able to give people this technology where they don't have to know a lot about WebRTC, but they can control and fly a drone, and this is all done via your browser. You know, you're dropping these operations and you're remotely controlling this device. It's incredibly powerful. And then you have like the IoT cameras cases. So WebRTC, like, don't think about it as just connecting to browsers. Like, you can connect with this with your remote cameras. You can connect with anything. Like, this is a protocol that it uses these standardized things that you can, like, this whole wealth of technology that came way before the browser is now available inside the browser because of it. And this kind of reinforces it as well, is someone wrote a terminal WebRTC client. So you can go download this binary. It's portable, and I got it from Mac OS and Linux. And here I am having a conference call with another person via ASCII just inside my terminal. And then the last story in this whole bridging of desktop and WebRTC is the file sharing. So like WebTorrent, Web Wormhole is a more, instead of peer-to-peer, it's kind of like a point-to-point file sharing. So I can download a Go client and I can share a file from my desktop to a friend just from their browser by using Web Wormhole. And it's end-to-end encrypted, and everything that flows over it is encrypted. So it adds a lot of that, like, benefits and that trust that what you're exchanging is safe. So those are all the things I want to talk about. I encourage you to go check out WebRTC for the curious. My goal is that it'll be a community work and it'll inspire more people to get into WebRTC. I think it's a great protocol because it empowers the small players to do interesting things, and the onus is put on the big players that are trying to ship these products and do these other things. It's like, we got really lucky with this, and I would hate to see the complexity of it stop from people using it more and more. So I encourage you to go check out these projects. I encourage you to build your own projects. I think there's nothing more empowering than the joy of building something that you own yourself. I don't want people to come build more stuff under Pion or under WebRTC for the curious. I want you to go build your own things, and I want to share them, and I want to see you become successful. And that's it. So thank you very much.
Thank you very much. Hope that was clarified a lot of things for people. It clarified a few things for me, but I think I'm going to have to go back to the drawing board and read WebRTC for the curious. On which subject, several people in the chat have said thank you very much for writing the documentation. In particular, Nico from Neko, the Matrix client, has been very enthusiastic in saying thank you. Apparently, it's been helpful for him doing debugging on his Matrix client. So that's really flattering, I think. So cool. We've got some great questions. So Dave, actually VoIP guy in the office, says WebRTC stack being built into browsers means that these implementations in the real world are dominated by a few large vendors. They're often written by companies that don't specialize in VoIP, whereas Skype and Zoom ship their own stacks invisibly, and they do that inside the binary. And doesn't that give them a big advantage? What's the future here?
Yeah, I'm torn. Like, I think that there is an advantage for the Skypes and the others of the world to have their own WebRTC client, but that doesn't help the individuals. Like, I want to find this good mix between, like, empowering the Skypes of the world to encourage them to keep using WebRTC, because the benefit is that long tail of all these individual users. So I hope that WebRTC can move to the point where they give enough hooks and enough places for these people to feel they still have a competitive advantage while still empowering everyone that uses WebRTC. So that's the kind of thing, like, you have to make both sides happy. It has to be easy enough that people that don't know VoIP can use it, but it has to be powerful enough that those people that want that competitive advantage, that they can still go do it. It's like finding that good mix.
Yeah, I mean, I really wonder how we can, I mean, I think you brought this up quite early on in your presentation, but the way to do this is to use the open source versions and that leads people to be forced, companies suddenly feel the pressure then.
Yeah, that's my hope.
Cool. Oh, so I was quite curious, and there's a few questions here about it. Regarding the primacy of do you show the immediate data, or do you wait and show a better quality? Is that something that a client can control?
Yes.
Okay.
So, yeah. So the client, so what happens is the sender will give you a bunch of packets, and each of those packets has a primary key, and that's it. So you'll just be sitting and you're getting all these packets, and I choose, like, do I decode these packets now, or do I wait a little bit and then decode these packets to wait for more to arrive? And so that's what's super powerful, is you get to choose the kind of experience that you want, and the browser actually lets you control that. There's a play out delay hint where I can say I want to wait 0 milliseconds, and like your video will be all garbled and gross, but it'll happen right now. But the browser by default tries to do like a variable latency to give you the best experience possible. Yeah.
Okay. Are there clients that enable the user to configure that?
Yeah. So I think like any client right now. So GStreamer is a really great one, and then the AOI RTC is one, and then the Google implementation. If you use like the C++ APIs, you can like plumb in and play with those things as much as you want. So really anywhere outside of the browser you can do that. And in the browser, in the browser you can touch it a little bit, but not as much as I'd like.
Yeah. So this leads us on to another great question, which is a lot of this talk is geared around the browser. You did give a couple of examples outside of that, but what's the situation when using outside on phones or laptops? So until recently, getting WebRTC in my small desktop application has been equivalent to embracing a Chromium instance inside of it. Any movement towards lowering this bar?
Yeah, so I would encourage them, go check out the GStreamer WebRTC implementation. GStreamer is great, like for embedded devices. And then there's a Python implementation, and then of course there's like the Go implementation. One of the downsides with the Go implementation is there's no like encoders or decoders in Go, and so you have to do like the FFI, and it's not like, I think it's a really great experience if you're invested in that, if you care about those things. But this talk is, I don't want to oversell Pyon just because I'm invested in it. Like there's a lot of great things. Like if like Go like Go, there's like WebRTC is a protocol, not just a singular implementation. So there's a bunch of stuff out there that is worth exploring.
Yeah, for sure. Somebody's asking, I don't even know if this is possible. Is there a VPN client over WebRTC? That's technically possible, I guess.
Yes. So if you search Awesome Pyon, there's it's called WireGuard RTC, and someone is running WireGuard over RTC, and so you can have 2 WebRTC agents, and then I think you can also in the browser like emit commands, and it'll go and do stuff for you. And then another interesting thing is there's a company called Tailscale, and what Tailscale has done is they've embraced the RTC. So they didn't implement ICE, but they implemented a lot of stuff that's very similar. And so a lot of this NAT traversal stuff is catching on more and more.
I see. Matthew, did you have thoughts and questions? I know this is a topic that you adore.
Yeah, it's my favorite part of the world, as Sean knows from geeking out about it. I actually had 2 questions. On the network stat diagram showing all the protocols, I saw that you had the ORTC API. And honestly, that was a bit which I'm a bit fuzzy on, because I never quite understood what was happening with ORTC. I spoke to Hookflash and those guys when they were working on it, and it seemed that Microsoft had hired them to go and build out this API, and it was going to replace the higher level WebRTC APIs, but then it didn't, but then it's still around. What's the story there?
So ORTC, it was like the idea was that they would give you a bunch of little components known as transports, and then you would get an SDP and you would configure the transports. And then like that's how WebRTC would work. And so in Edge, there actually wasn't like a create offer, create answer. Like there was like the create offer, create answer, set remote description. It went and configured all the little components. And then, so what's been happening now is more stuff has been folded in from ORTC. So like WebRTC, like you're slowly getting more bits and pieces of ORTC. But then the hard part, like honestly, being like an individual, like I am totally reactionary to whatever Microsoft and Google chooses to do. Like I find out about it after the fact. But no, I'm a big fan of it. I'm always torn on like, you want things to be easy. You want to be empathetic to the user that doesn't really care about WebRTC. They just want to get 2 videos in their browser and they want to start talking to each other. But then you also want to empower like the hackers who want to build cool things. So I think there's like a good middle ground. I'm a fan of the ORTC stuff. Like I'd like to see more of it.
Cool. And my other question is kind of doubling down on Dave's thing of where is the future with respect to WebRTC versus proprietary or custom VoIP stacks. And I was kind of interested in the article that Sahi Levin-Levy wrote a few weeks ago called Unbundling WebRTC. Where if you Google folks for WebRTC unbundling, you get this rather interesting sci-fi experiment where he posits that WebRTC could just get split up between a web transport layer, which is just for transport, and then codecs as a separate thing, and then possibly a WebAssembly framework for doing other things, and almost let people build their own WebRTC stacks in WebAssembly. What do you think this is based on reality? Is this complete sci-fi?
I think there's like the 2 part. Like I think technically the WebAssembly stuff excites me more because the idea that the WebAssembly stuff will be memory safe. So we've had vulnerabilities with the C++ code and stuff like that, and that's not something that I'm a big fan of. And so technically, I think the web transport stuff is really exciting because you get these little building blocks and you can do powerful things and it will help people build like their interesting things. But then the thing that scares me is where does that leave, the individual? So we have someone that's not technical, they want to build their conferencing application and I say, okay, like do web transport and then implement your own congestion control. Like that's never going to happen. And so then the thing I wonder is like, should I go build, like when web transport comes out, should I go build my own web transport stack so then people can build things? But then am I enabling a standard that I'm not fully behind? It's a complicated thing. Like I don't know exactly how I feel. Like that's all the places I'm at. But I think it is technically possible. And I think like people are pushing very, very hard for it because like so much money was invested in WebRTC, and now all of a sudden you have other companies that are making billions off of it. Like I can't imagine how frustrating that can be. But then I don't really care. Like I care more about like enabling people to build their little things. So those are all my rant.
Google just wanted more people using the web so that they could sell more ads. They don't care if other people go and make billions out of conferencing on it.
Yeah, that's like as I spend more and more time in this, I realize how complicated it all because there's like the company's motivations and then there's individual motivations. Like I didn't realize how much people identify with how many IETF drafts their names are on. Like, you have people that like I came into this kind of oblivious, but then I realized like people will talk to you and then they'll go do a draft with your idea without even telling you and like stuff like that. It's a very political, interesting thing. I'm very naive and like very like happy-go-lucky kind of person, and so it's complicated and like there's politics to it, there's technology to it, but I enjoy this little part I'm in.
Awesome.
That's fab. I really need to check out WebRTC for the curious. We're going to make sure that the right links are in the right places on the correct pages on YouTube and on matrix.org. Thank you, Sean. Thanks again. I really appreciate that. We have one more to show you, and that is Damir. Damir works for Elements. He works on matrix.org, and he has been working on all kinds of things. But in particular, we're going to hear him talk about the Rust SDK and his work to get that up and running, and also to get end-to-end encryption enabled in that, and maybe he's touched on other things as well. I think we're going to do this as a dialogue, Matthew and Damir. I'll let you chat.
Wow, okay. God, you could have given me some notice, Ben. Hi, Damir. Are you out there?
Hi.
For the record, we did.
I'm just being mean to Ben. Sorry. So, Damir, tell us about how you discovered Matrix, and let's get a bit of background before we jump into the Matrix Rust SDK hacking that you've been doing, which is very, very cool, but we should get some context.
Yes, so I started looking at Matrix, I don't know, 2017. I used WeChat with Littlebee to use to chat over XMPP, and crypto was very flaky, so I looked around and discovered Matrix, and I wanted to continue using WeChat. And there was a plugin for scriptwriter in Lua, but it had performance issues. The crypto didn't work anymore since Matrix transitioned from Ohm to Mega Ohm, so from double ratchet to a symmetric cipher, and I waited so the script got updated, but it never came, so I decided to write my own in Python.
So that was built on top of the Matrix NIO library?
Yeah.
So explain to us what NIO means. I think this would be very interesting for all of the network developers here.
Yeah, it's a concept. I think it mostly started in Python. So you built your protocol implementation without any I/O. So all the sockets and stuff is pulled out of it, and you only do your protocol as a state machine. And then you layer on top of it your socket and do push bytes into a socket and pull bytes out of the socket and push the bytes into the state machine and pull them out again. So it started in WeChat, but I pulled it out of it into a library, which became useful to other people.
And so is there any event loop there at all, or is the whole point that you plug someone else's event loop into the NIO library?
Yeah, so in WeChat has its own event loop, and you can create a socket in WeChat, and you can get callbacks called when you can read and write to the socket, like poll. So you can then create a state machine, and from the WeChat created socket, you just pull and push bytes into it and then into the state machine. So the design of NIO is guided by this idea that I can create a socket that doesn't block in WeChat, but I need to transfer the bytes into a state machine that talks my protocol.
Makes sense. So, and that's done using async IO and Python 3 type safe stuff and all the latest Python bits?
No, in WeChat, I tried to implement a async IO loop in WeChat that uses the event loop of WeChat, but it didn't work for various reasons. I have no idea, to be honest. It uses the callbacks, and it quickly grew into callback hell in Python. The Rust reimplementation does implement a runtime in Rust, so you have a executor, and you can execute the async futures in Rust. So callback hell is avoided, and a modern code base is used in the Rust implementation.
Okay, so you spoiled it already. Is this Rust re-implementation of the Matrix NIO Python plugin for WeChat? So what similarities are there between the Python NIO approach and the Rust one? And also, why Rust?
So why Rust? It allows you to teach old dogs new tricks. So you have in WeChat this executor, you bring in async code into WeChat, you bring in thread pools, you have connection pools, and you have this 15-year-old chat program that suddenly has a modern code base. Well, at least the plugin part, the core is still C, but the Matrix plugin is a really modern code base and runs inside an old code base. It's guided by the desire to swap out modules in Firefox, I guess.
So how many other Rust plugins are there for WeChat?
Somebody discovered my WeChat library for Rust and is building a Discord plugin. I have a bunch of examples. For example, really fast grep implementation inside of WeChat, so you can search your logs quite quickly using grep from Sushi. And yeah, just a couple of examples. I don't know if people will start building more plugins using Rust. The WeChat IRC channel wasn't that excited about it. At least it's useful for me. And
so how does the Python Matrix NIO plugin compare with the Rust rewrite?
So it's the Python version is, I guess, a sloppy version of it. I'm using the power of hindsight to make stuff nicer, and obviously I have the Rust compiler to guide me and to tell me if I have typos or try to push types somewhere where they don't belong. So yeah, it's a more polished version of the same concept and idea.
Because do they have kind of similar class models or similar architectures? Because I know that you've been proofing out some of the work on the Rust SDK by going back to the Python code base and doing it in NIO and then porting it back forwards to Rust. Are the two kind of staying in lockstep?
Yeah, mostly yes. I mean, the thing I prototyped now in the Python implementation was the cross-signing thing. So the crypto layer is mostly the same, but better polished. The verification events types and that we're using Rumor. In the Python version, it's all a sloppy class hierarchy and JSON verification using JSON schema. And in Rumor, we're using really strong types to model all the events and the requests.
That can be a tricky thing on the verification flows, not just because the events need to be better specified, which is my fault for not merging the matrix spec changes needed fast enough, but also the state machines for the verification dances. We had a lot of problem on Element when implementing them to try to decide what was actually a valid verification handshake and what wasn't. Should we be doing Postel's law and being really flexible about what was accepted, but really stringent on what we send, or should we be really stringent on what we accept as well? And honestly, I'm not sure we've got good answers on that. It's one of the things that needs to be clarified on the MSC. But do you have a state machine for the verification process then in the SDK, the Rust SDK?
Yeah, so the verification flow is implemented as a type-safe state machine. So when you do verification, you have different events. You start the verification, then you accept it, and you go through stages depending on which event you receive. And you can encode the transitions in types. So we did that. If you have a verification that is started, you can only transition to the next state of the state machine if you receive one type of event.
So how does that work? Because surely you only know at runtime what types are flying around that the transitions that you're trying to do at runtime. How can you impose the type safety of that at compile time?
Well, to transition to another state, you need an event. Mm-hmm. So you encode that one type represents one state, and to go from one state to the other, you need to consume an event. So if you create this start object and you then receive an accept from the other side, you can transition to the next state. And it consumes the object, so you can't reuse it anymore.
I see. So the state machine is effectively just implemented as a thing that is consuming the events and the, oh no, I'm still not quite getting it. Because again, it sounds like it should be runtime type inference of some kind, that you get your event coming into the state machine, it looks to see what it is, and then it does the transition for you, rather than something that could be imposed at compile time, metaprogramming stuff. I think my C++ is showing.
The thing that receives the event originally checks at runtime which event it is. Then it finds the verification object. If it matches, it gives the verification object the event. And you can only pass one type of event to transition to the next state.
Yep. Okay, that makes sense. And is very cool. What about bindings to other languages, hypothetically?
Yeah, one reason why I'm doing a completely separate crypto module is to allow other people to create bindings into other languages. And of course, selfishly, I want to reuse it in Neo, in Matrix Neo for the Python implementation. So I don't have to maintain two crypto implementations.
Okay, so that's interesting. So rather than swapping out all of Matrix Neo on, say, WeChat with the Rust implementation, you are also swapping out the crypto implementation specifically and moving it from Python to Rust.
Yeah, correct. So it could end up that the Python WeChat implementation gets cross-signing, but using Rust.
Okay, but you're also going to have the native Rust plugin as well.
Yeah, of course, because the Python thing is one thread, one socket, and it all magically works decently well, but it's callback hell, so it's maintenance burden.
So this is really exciting news for all the Python SDK people who are suddenly going to get cross-signing and all of this next generation E2E features, with a minor catch that it's actually going to be Rust. We just don't want to tell them that.
Yeah, I mean, I should provide a binary wheel for Python, so that you shouldn't really notice anything.
Cool. And what about some C bindings for it? This is a bit of a stupid question, given it's one I've been playing with.
Well, the Python thing generates C bindings, so equally you could generate bindings for other languages or for C.
Around the Matrix and IO layer? Or around the Rust layer?
Around the Rust layer.
Okay. So hang on, you're saying that, so what would be generating the C bindings for Rust?
Probably, what was it called? BindGen or C BindGen.
Yeah, okay. So it's one of the Rust BindGens.
Yeah.
Cool. So where is the Rust SDK being used apart from WeChat?
Daydream is one of our prominent examples. It's I guess now it's a desktop and web client since MTR not swapped to another library. So it compiles down to WASM for the web client, and it compiles, I guess, natively for the desktop clients. It has still problems with the storage of the crypto keys in the web layer, but we are working on that. There's IndexedDB implementation of a storage layer, and hopefully that will get finished one of these days.
Do you know how performant it is in terms of like RAM footprint? I mean, how big is it to run a Rust WASM app inside a browser? Does it go and like allocate a couple of gigabytes of heap to work with? Or
I don't know, but hopefully not that much.
Cool.
Other examples, Rumatui, that's a small toy example. Fractal is swapping out to use the Rust SDK. They are switching slowly each request to use the Rust SDK. Sadly, they still didn't swap out their sync loop, which will enable crypto in Fractal.
Well, if it's happening, so is that merged or is it on a branch? Do you know?
It's a PR that's work in progress, and Alidomo is working on it. There were commits yesterday on it, so it's actively going on.
So I had a ping from Todd, the CEO at Purism, last night, asking whether Fractal was going to have end-to-end encryption anytime soon. And I was happy to be able to say that there was a very different answer to like 2-3 years ago when the Librem 5 first started talking about Matrix use, and the Rust SDK could be a good way forwards there. So you never know, you might discover it live on your nearest Librem 5 fairly soon if the Fractal guys get it working. So what's the deal with storage for the SDK, whether that's crypto state or your local history? And how does that tie in with the work that Bruno has been doing with Hydrogen, the lightweight next generation Matrix client that he's been playing with?
So because we try to be flexible and run everywhere, we need to abstract to our storage, because under the web you can't access files normally. And we model that out as traits. So you get a trait for your crypto store, and you need to implement, I don't know, 5-6 functions, or maybe a bit more, to store these types of keys, these types of devices and stuff. And yeah, we are using SQLite on our main implementation. There's a default implementation that uses just in-memory stores that's usable for any type of client. So MTR uses it on Daydream. Everything is in memory. Once you swap out, refresh your browser, your storage is gone.
But you've given him a new trait which backs it by IndexedDB for the crypto state.
Yeah, so we have a memory implementation, as SQLite implementation, and a prototype in IndexedDB for the crypto store. The same thing should be going on for the state storage. It's not there yet. There's only just a simple state store that periodically dumps a JSON file on your disk. And same thing on the web. It's just keeping stuff in memory, and when you refresh, it's gone.
It seems to, in some ways, be the holy grail for Matrix clients that we honestly didn't understand early enough, that how you go and store the local state and how much is in memory and how much is persisted is like critical to the architecture and the performance of the platform. So originally on Vector, as it was, we didn't persist it at all. So every time you fired up the app, it did an initial sync and it would suck it all into RAM, and it would sit there with hundreds of megabytes of JavaScript heap. Then as a quick dirty fix to avoid having to initial sync, we went and just persisted everything in RAM down into IndexedDB as a single JSON blob. And that's basically still how it works today, because we've been running around adding features and doing all the other things. And I think the point of Bruno's stuff with Hydrogen is to experiment with the polar opposite, where you don't store anything in RAM. And the very first time you start getting messages and room members and state, you immediately persist it to IndexedDB, to the various different tables. And then whenever you want to render something, you pull it out of IndexedDB. So you get these freakishly small RAM footprints, like 10, 12 megabytes of RAM for the entire app, because in practice, all the data is actually being stored on disk in IndexedDB. Do you see architecture with Rust SDK that could let you go on a crazy minimize my memory footprint bender like that?
So the crypto store can be implemented that way, but since storing encryption keys goes through an encryption cycle, we store them encrypted. It's a bit better to cache stuff and not load everything, but as you load, cache it. So it's a bit of a middle ground between the keep everything in memory and keep everything on the disk. For the state storage, I think it's still a bit usable to cache stuff, but mostly keep stuff on the disk, since I guess we are using SLED as an experiment. I haven't looked yet into it much, but SLED seems promising. On Conduit it works quite fast, so that might enable us to go the Bruno way and keep stuff on the disk.
Very exciting. We'll have to have a shootout between the heap sizes on pure JavaScript and pure Rust as, I know, native versus WASM, and see where we can get the smallest footprint. And it's really fun to have next generation Matrix clients like this out there. I'm reliably assured that Neko already had this architecture years ago and nobody noticed. Sorry, Nico and Mujex, that we didn't quite realize that. Otherwise, we could have incorporated it much faster.
Yeah, I checked out the Neko implementation, and it's similar as well. Though there it's one store for the state and for the crypto. So we have it split up.
So the Rust SDK is a bit of a labor of love. Obviously, Element is funding the development of it for the greater glory of Matrix as a whole. What are you most excited about with it? Are there any particular use cases or things you want to build on it, which are particularly exciting?
Well, obviously, WeChat, the WeChat
apart
plugin.
from WeChat.
I don't know, perhaps the conduit inside of the Rust SDK as a peer-to-peer client sounds interesting. We actually implement the HTTP layer as well as a trait. So you can swap out your HTTP library, and we could just swap out conduit as a HTTP client and call directly conduit.
So would that have the exact same architecture as the Dendrite peer-to-peer, where it's essentially just munging a home server and a client together?
Somewhat, but you embed your whole server into a client, and also you swap out HTTP for direct function calls. So
you could be even faster and beat Dendrite at their own game.
Yeah, I don't know how much progress is on that side. Devin R. and Timo were working on that, but it does sound exciting, and I might look into it and helping out a bit later on.
I think honestly it could be an awesome idea, because on the peer-to-peer mock-up we have at the moment, obviously you've got Element Web in JavaScript, or TypeScript, I guess, then talking over HTTP over the service worker API to Dendrite running in WASM compiled from Go. So it's a real mutt, complete with the persistence being stored in IndexedDB. And in that instance, we're having to go from Dendrite in WASM talking SQLite in JavaScript, and SQLite then stores it as a binary blob stored on a file system layer, which is emulated on top of IndexedDB. So it's literally 4 levels of storage indirection disaster. Whereas if I understand the proposal from Timo and Devinar and Polya here correctly, you basically share the same SLED database engine between both the client side for the state storage and the conduit server. It's all in Rust, it all compiles into a single binary image, and you just put a little bit of UX on top for the client, whether that's Daydream or Fractal or WeChat, and you have yourself your fully self-contained peer-to-peer matrix node, hopefully talking the same protocol as whatever we have on the Dendrite side. So it's just next generation peer-to-peer matrix with the Rust team going up against the Go team for a change. So I think it's a really, really exciting possibility, and can't wait to see what it looks like and which goes faster, and we can have lots of benchmark comparisons with Timo again.
Yeah, one big goal of the Rust SDK is to be as pluggable and as, I guess, usable in many use cases as possible. So you can swap out one layer, you can remove one layer. You can just use the crypto layer in your auto language and swap out plugin stuff as you like.
So I've got a project where I've been playing with it a bit on macOS, hooking it up to Swift UI, which is problematic because Swift and Rust doesn't really have a good mapping right now. Rust has its own idea of strings and Swift has its own idea of strings. Both of them have C strings as a compatibility, but you have to convert back and forth between the two. And until a few weeks ago, nobody, I think, had seriously tried to do Swift directly to Rust or vice versa. So what I've been trying is to use the cbindgen stuff in Rust to expose C wrappers around what Damir's done, and then go and hook it up as just a plain old C library from Swift to experiment with native iOS and macOS Swift apps, which happen to use the Rust SDK rather than our old Objective-C iOS kit and iOS SDK. It's pretty early, but I got it to build at least and got it to log in. So it will be interesting if I can find any spare time to play with that a bit more. Cool. I think that was all I had in terms of questions on this, Damir. Thank you for letting me grill you on all the latest Rust SDK stuff.
Thank you for having me.
Well, thanks for coming on Open Tech Will Save Us. I feel like we've done the entire gambit tonight, going from censorship and moral ethics online to the Go team represented by Sean and the Pion community and all the WebRTC for the curious stuff, and then we've gone firmly over to the Rust dark lens. So we've had it all here tonight.
Yeah,
I'm stolen Ben's job. Back to you, Ben.
That's the goal. I mean, the idea is that we want to make sure that we want to talk about the technology and the real impact it has, and also the actual nuts and bolts and the concrete. What are you going to do?
I'm going to steal your camera. He didn't want me to come and steal his camera earlier.
Your remote. You want to be on here? All right. Echo. So I want to say thank you. Thank you very much to Ajim, who is from Quadrature du Net and has been talking to us about censorship and the decentralized world. Thank you to Sean Dubois, who gave a stunning introduction to WebRTC. And also, I encourage you to read his existing work, which is WebRTC for the Curious. I'm certainly going to be doing that. Thank you, Damir, Polya, not just for being on here, but thank you for your work and producing Matrix Neo and the Rust SDK and Seshat and Pantalaimon and so many features of Matrix that make it really, truly usable rather than a conceptual protocol in a lab. So thank you to everybody for being involved, and thank you for watching. Bye.